In this video, I'll show you how to configure OSPF Route Summarization on the NOKIA 7750SR. Route Summarization is used in multi-area OSPF network design to reduce the size of the OSPF database and to simplify the SPF calculations within the areas. In the previous lab, we configured Area 1 and Area 2. In this lab, we will configure loopback interfaces to simulate 3 networks connected to Router 3. We will then configure Router 1 to summarize these networks into Area 1 and Router 2 to block the same networks from being summarized into Area 2. I have broken down the task into the steps as shown in the list. Let's now go to the CLI and begin. Our first task is to configure 3 loopback interfaces on Router 3. The second task then says we need to advertise those loopback interfaces into Area 0. The third task says we need to configure Router 1, which is the ABR in between Area 1 and the backbone area. We need to configure a summary route for the 3 loopback interfaces that we created on Router 3. This will then be advertised as a summary route into Area 1. Lastly, on Router 2, which is the ABR in between the backbone area and Area 2, we need to configure Router 2 to block that same summary route from being advertised into Area 2. So let's get on with it. Before we begin, let's check what we currently have in the routing table on all our routers. So we usually show router route table for that. So currently on Router 5, which is in Area 1, we have 13 routes. On the ABR, we do the same thing. We should have the same amount of routes everywhere for now. So we again have 13 routes on Router 1, on Router 2, which is the ABR in between the Area 2 and our backbone Area 0. We issue the same command, route table. We should have 13 here as well. They should all have identical route tables before we start modifying things. So on Router 6, which is in Area 2, we should also have the same thing. So here also we should have 13 routes. We then also need to verify that we can reach those that will be done after. So let's go to Router 3 and create those 3 loopback interfaces. If you remember from the NRS I series, to do that we usually configure router interface. We want to call this loopback 1. Return our address. For this will be 192.168.3.1/32, and we need to tell the CLI that this is a loopback interface, and for that we issue the loopback keyword. Enter, exit, and to speed things up you can arrow up to the initial command and edit them as you need. So for this we'll change this to loopback 2. This saves us from typing everything all over again. Hit return. If you arrow up here also you get to the address, you change that to .2 for loopback 2, and don't forget the keyword loopback. Again, exit and repeat the same thing for loopback 3. So arrow up, get to the loopback, change that to 3, return, arrow up, get to the address and change this to 3 as well. Hit return and don't forget the loopback keyword. Exit all. Check to make sure those interfaces are available. Show router interface. We have our 3 loopback interfaces, admin and operationally up. So that's task 1 finished. We then need to add these 3 loopback interfaces into our Area 0, and to do that configure router OSPF area 0, return, interface. If you tab here, it will show you all the available interfaces. For our purpose, we only need loopback 1, 2, and 3. So we type in loopback -1, type in back, because we don't want to exit, we just want to go one level back. So you issue the back command, hit return, and again you can use your arrow hop here. So arrow hop, get to that interface loopback 1, backspace, change 1 to 2, return, again back to get back to the area, the previous higher level, return, arrow up to the loopback and change that to 3, return. Now you can exit all to come out entirely. So again, to verify, let's do show router OSPF interfaces, return. We should see all our OSPF interfaces within area 0, and as you can see, we've now added loopback 1, 2, and 3 to be part of area 0. So let's now check our routing table on all those all the routers that we previously checked. When we checked earlier, we had 13 routes. So let's check to see and confirm that those newly created interfaces within area 0 are being advertised into all the areas. So just arrow up and run the same command again, show router route table, return, and this is on router 5, by the way. So as you can see, we now have 3 additional routes in router 5 route table. We have the 192.168.3.1, the .2 and the .3. They're now available. Also, let's run some connectivity check. So can we reach it? Ping 192.168.3.1, the first one. Yes, we can. And then let's check, make sure we can reach the second as well. Yes, we can. And then the last one, which is the .3. Yes, we can. So on router 5 within area 1, we can now ping those newly created interfaces within the backbone area 0, which we created on the router 3. We also noticed that we have those routes being advertised to area 1. So we then need to go on to router 6 in area 2 and double check the same thing. The last time we checked, again, we only had 13 routes. We should have those additional loopback interfaces here as well. So if I arrow up again and hit return, as you can see, we have the 3 additional routes as well. So if we just do one more command, show router OSPF database. Just want to see something quickly here. I want to see where. Right. So as you can see, they are available in area 2. Those are the 3, and they are available as summary routes. Like I mentioned in the summary video, every route is a summary route in OSPF. They're being advertised by the ABR as summary routes. So that's concluded the first and second task, which was to create the loopback interface and then advertise those loopback interfaces into area 0. We now need to go to the ABR in between our area 1 and the backbone area, which is router 1. We now need to configure a summary route with the 192.168.3.0/24 to be advertised towards area 1. So let's go to the ABR router 1. So here, all we're doing is we're configuring the summary route to be advertised towards area 1. And for that, we should configure router OSPF area 0 area range, yes, is 192.168.3.0/24 advertise. Yes, don't forget that keyword. That keyword is the main thing here. we're saying we want the OSPF area range for this address to be advertised on that ABR. So hit return. Now, before we go on to the router 2 to do the same thing, which is not the same thing, to do the reverse of what we just done here, let's verify on router 5 what has changed in the route table. So again, arrow up, get to the command that you need, show router route table, return. Now, those 3 individual routes that we had before, the 192.168.3.1.2 and .3, they've all been replaced by one summary route of 192.168.3.0/24. Let's verify and make sure we can still reach those addresses though. So we want to ping 192.168.3.1, return. Yes, we can still ping them. And then let's do the .2 as well, just to be sure. Yes, we can ping .2 as well. And then let's do the last one, which is the .3. Yes, we can ping .3. Now, before we go on, let's check on the ABR's route table, what has changed. What we had before was this. We had all this here. So let's run our... This was before we created the summary, yes? This was before we issued this command. This was a route table before. As we can see, we had the 13 routes there. So let's see what's changed after we issued this command here. So let's arrow up again to our show router route table, hit return on the ABR. And I want to show you something. So you'll notice something here now. Can you see that? It's a black hole. So the route table on the ABR has only changed. What's changed is it now includes a black hole address. What does that black hole do? Now, this will match any address that does not exist within the 192.168.3.0 range. So if we go back to router 6, yes, and ping, for instance, a .4 address, which we know doesn't exist, and hit return on that, as you can see, nothing's happening. So it's saying request timed out. I'll explain what's happening here for you. Router 5 is sending those requests like it did for the .1 and .2.3, sending them towards router 1. Router 1 has checked within its routing table and could not find the .4. Therefore, the .4 matches the black hole. So what router 1 is doing is silently discarding that address. If we go to router 3 and create a for loopback address of that address, which is 192.168.3.4, that will work. That command, this ping will be successful. But because the ABR now has a black hole address that matches any route that does not exist in the range 192.168.3.0/24, it will silently discard of it. I hope you understand that. So let's go to router 2 and do the reverse of what we've just done here. And the reverse of that, as our task says, let's go back to our task quickly. Configure router 2 to block the summary route 192.168.3.0/24 from being advertised towards area 2. So on router 2, we need to configure that. But before we go, on router 6, let's show the route table again, because this is going to change after we've finished our configuration. So you can see we have those addresses here. We have the 192.168.3.1, .2, and .3. And also, currently, we can ping those addresses. let's try from here, from area 2. So ping 192.168.3.1. Yes, we can. .2. Yes, we can. And .3. Yes, we can. So before we issue that configuration, which is going to block the summary address, we can reach those addresses there. Again, on router 2, which is the ABR, we have the previous copy of the routing table, which is the which only had 13 routes there. So let's now go ahead and issue the command to block the summary addresses from being advertised towards area 2. And to do that, we issue the configure router OSPF area 0 range, area range, beg your pardon, area range 192.168.3.0/24, but not advertised. Can you see that? We are not advertising this towards area 2. It returned. Now let's go back to our router 6, which is within area 2, and see what has changed. We previously had 16 routes in the route table. Let's show the route table again. Now those 3 routes that we created on router 3 have been removed from the routing table of router 6. We're now back to 13 routes. It's almost like, yes, those networks don't exist. Yeah, router 6 does not know about them because the ABR router 2 is not advertising those networks towards router 2. They're invincible to router 6. Also, if we try to ping those addresses now, 192.168.3.1, no route to destination. I don't know how to get there. They don't exist as far as I'm concerned. Yes. So on router 2, there's also something I'd like to show you guys. Let's show the route table again. And let's see what's changed. Nothing has changed. So we still have our 16 routes. No black hole has been created here, by the way. Let's compare this with the ABR router 1. We have a black hole here because we are summarizing a range towards area 1. And we want to put a black hole in our routing table for routes that does not exist in that range. Yes, that will discard anything that does not exist within this range. It will be silently discarded. But because we are not advertising anything towards area 2, we don't have a black hole route here on router 2. So every time you run a summary, if you create a summary towards an area, you will have a black hole. Yes, if you create a summary, or if you block a summary from being advertised into an area, you don't need a black hole. So the router doesn't create one for you. So what is the main use case here is the question. So imagine an ISP where a large ISP, maybe a tier 1 ISP, where you have many routes coming into your route table and from the same location. I mean, and you've done your IP address plan properly. You really don't need all the routers within your network to have a large routing table. If you can do route summarization, this saves the processing on the routers, and also the memory. You know, that's the main use case really for summarization. It reduces the CPU as well for the routers running the SPF algorithm. So it's a very, very good tool for reducing the size of your routing table when you have a proper IP plan. You know, so that's the main use case. Some people will also say, say for instance, those 3 addresses that we are summarizing, those are like a secure network, if you like. And this, let's go back to the diagram and I'll show you what I'm trying to say here. So let's imagine that these 3 subnets here are security zones, if you like, that you don't want everybody within your organization to know about them. You only want a few people. Maybe area 1 is a secure area and area 2 is a non-secure area, for instance. Yeah, you want people within area 1 to be able to reach these networks, but people here, because maybe you're sharing that same network with your third party, maybe you have a lab or something here that is being accessed by your third party partners, and you don't want them to know about this secure part of your network. So you can block, you can configure your ABR in between that area, the non-secure area, to block off those subnets. So these people here will not know about them, but your secure section within your network will be able to reach them. Obviously, I mean, you will still have the other secure, elements that we all use, like firewalls and access list, of course. But also, this is a way, like a bare bone level security, if you like. So, I mean, but the main use case really is to reduce the size of your OSPF database. I hope you find this useful, and thank you for watching. See you in the next video.